Thank you all for joining today's session. I'm together here. My name is Meir Sawdayee. I'm together with Yair Zarka. We are both product manager at Microsoft Defender for IoT. And we are both highly experienced. We are Blue Team Defender, and we have both of us, or each of us, has actually nearly 10 years of experience to secure IoT devices, whether they're an embedded system, ICS system, and so on. So it's great to be here. So the agenda for today is, first of all, highlighting and discussing what are the different Defender challenges, specifically in the OT and IoT network. Then we will discuss how we can address these challenges and provide you with the visibility to see into your ICS network. And finally, we'll talk about our unique infrastructure, the deep packet inspection and Horizon, in order to perform this deep dive security and provide and secure and protect your different devices within the ICS network. And finally, we will leave time for Q&A. So before we start discussing about the different topics, I would like to provide a brief overview of our product, Microsoft Defender for IoT. So first of all, Microsoft Defender for IoT is a unified platform, a single platform with many capabilities that can address the different pain points that customer may have while adopting IoT and OT devices. That means that our product is intended for two types of users. The first user is the user who is now using these IoT devices, whether those devices are in the OT network in the production line, or whether it's within its enterprise network, whether there are IoT devices, fire alarms, cameras, and so on. And the second type of users that are using Microsoft Defender for IoT are device builders, the ones that are now building IoT devices and they want to secure them in advance before releasing them into production. Now, our strategy is from design to security operation, meaning that our goal eventually is to secure every IoT device that you have in your organization end to end. So we start with building device in a secure manner. And on top of that, our goal is to provide the security operations while using IoT and OT devices with the security and protection that they need in order to do so. And in order to achieve this capability, we have to rely on a wide range of protocol coverage and eventually discovery. And that means that we need to support a large breadth of protocols, but we also need to support each and every protocol in depth. That means that in order to provide the SOC with the visibility of understanding of the different threats that they now have in the organization, we need to also provide them with the understanding what is the exact threats and eventually how it can impact the entire business in order to address it correctly and triage and understand what is a critical threat that needs to be addressed right now. So now that we provided this overview, let's dive into the different Defender's challenges. So first of all, a little bit of background on OT and IoT devices. These devices are usually built in a mindset that they need to work. Every OT and IoT devices need to do the same operation over and over again. And the name here is, and the main thing here is stability. That means that those devices were not built with security in mind. And those devices usually need to last for tens of years in the different plants or production lines. So that eventually, even if they leave the factory as secured, as time goes by, we are receiving more and more vulnerabilities, more and more risk on those devices. And eventually, it's almost impossible to patch them. And to add more complexity on top of that, each vendor now has its own proprietary protocols, its different implementation to those devices, and eventually you need to support this large set of devices in a secure manner, which makes this challenge even more complex. Now, in recent years, we also see a major trend. We see that the number of IoT and OT devices is increasing. And eventually, from a security standpoint, it's led to the fact that the attack surface is growing. That means that you have more devices right now and eventually you need to protect them, because we're seeing them more and more. There are more devices that are connected between each other, more devices that are connected to the internet, whether it's directly or via the IT network. But eventually it leads to the growth of the attack surface. And as time goes by, we see more and more OT and IoT devices rather than the IT. So this is becoming a prominent problem that we need to address and eventually secure. Now, in addition to that, we also see another trend that is happening and increasing in recent years. And that is that if before we had a standard OT protection or IoT protection and IT, each of them was its own segregated network. Now we're seeing that the boundaries are getting blurred. That means that we are seeing, for example, in the production facility, the traditional OT environment, we are seeing now IoT devices. They can be Raspberry Pi, for example, with different sensors, whether it's a humidity sensor, a temperature, maybe a camera that needs to monitor the production facility. So eventually you have these IoT devices in the OT network. And another example is the building management systems. We're seeing that buildings are being controlled smartly, whether it's elevator, whether it's HVAC system, and eventually you have also OT devices within your enterprise, within your IT network. So you see that all of the boundaries are getting blurred eventually, and you need to secure all of these devices. And in order to do so, you need to have an holistic approach in order to secure your entire network and all of your devices eventually in the organization. Now, if we look back, we're seeing that if we had a traditional IT security, you have a set of devices that you need to secure, and they are usually well managed. You have high visibility to them. But as time goes by and we're seeing more and more IoT devices, we are seeing that the attack surface is growing because more devices are now getting digitally connected. As part of the digital transformation that each organization is now doing in order to make the work of the organization more efficient. But we're also seeing additional trends like bring your own device and more IoT devices that are being added. And eventually that leads to more and more devices. And from the adversary point of view, eventually you see that you have low-hanging fruit. That means that the IoT device is usually the weakest point in the organization. It enables them to achieve a foothold within the organization and then maybe spread and perform lateral movement to additional threats. And of course, once you are now impacting the IoT and OT device, you can cause physical damage and bring down to the production shutdown or eventually organization shutdown, and this can impact heavily the business. And we're seeing several trends here. That means that we're seeing also the attackers getting more and more sophisticated. And by the way, you don't need to have a nation-state capability in order to perform an attack. Now we have ransomware as a service. You can pay and reach a specific group of attackers, just pay them and they will provide this service for you. In addition to that, from the security perspective, you see that you have many tools, many security tools in different shapes and sizes that usually don't communicate between each other. That means that you need to train your SOC to use those devices, but eventually where they're not connected and integrate between each other, it's very hard to control them and to achieve complete visibility within your organization. And finally, this is something that is being generated because we have a lot of devices. We're also seeing that the data is increased. We have a lot of noise, and the main challenge here is to turn this noise into insight. Our goal and eventually is not to flood the security operation with noise and alert fatigue, but eventually the idea here is to provide them with insight in order to be focused and be in context in order to remediate the threat as fast as possible. Now you can see example from recent year on OT and IoT attacks that happens. We have, of course, Triton that happened in 2017, and how attackers can, in addition to cause physical damage and business shutdown, also try to harm human lives. in a chemical plant in the Middle East. We also have an example of the Colonial Pipeline, an oil and gas attack that happened in the US last year. And we're seeing more and more attacks, more and more cases where it's much easier for the attackers to control and impact those businesses and eventually shut them down in order to receive what they want eventually. So these attacks and the attack surface eventually leads to all of these numbers. And eventually, I want to focus on the bottom number in the yellow, the 31%. And that means that the IoT adoption and adoption rate is being slowed. 31% of the CISO are concerned because they have security risk within IoT and OT projects, and they are concerned, and eventually they want to slow down or even shut down the digital transformation process for the organization. So this is something that we must protect and secure in order to provide them with the confidence to perform this transition and make the organization more digitalized, more efficient, and eventually provide better value to their customers. So now that we covered the different challenges in the OT and IoT network, I want to highlight how we can achieve visibility into the industrial controlled networks in order to secure them and ensure that the organization is now working as appropriate. So let's first of all understand what are the main pain points for the organization that we want to address. The first one is asset discovery. Usually this is the initial point. In order to provide security to organization, you need to understand what do you have in your network. You need to shed light on the different devices. What are the devices that you have? This is the initial step in order to eventually secure and protect these devices. Now, another thing is to understand the organization risk level. Usually customers don't understand if they're exposed to malicious threats, how they can secure the organization. They don't have this visibility. And to understand, even if a risk hasn't occurred yet, they need to know if they're exposed and on what level. And eventually, they need to know how they can secure the crown jewels. What is the business impact that can happen at the moment? So this is something that needs to be addressed as well. And also when a risk has been realized, that means that if now an incident occurred, you have a malicious malware in your network, you also want to gain the visibility, the real-time indicator that you now have a malicious threat that can spread across the organization and can cause damage that might be not reversible even. And in addition to security, some of the issues and hazards that may happen might be related to operational efficiency. As you know, OT and IoT networks are very sensitive. So if we're now, for example, seeing a multicast request to all of the devices, and some devices are being flooded with multiple operation, it might cause a downtime and operational hazard to the organization. So even if it's not driven by a security standpoint, it's still something that is really important to provide with visibility that maybe something is misconfigured. And finally, you need to provide the organization with cross-network monitoring. Usually we're seeing that the organization has an IT SOC, and if they want, they can add also an OT SOC or OT site manager, but eventually you want to unify them. In order to provide them with the realization that you have now a cross-network threat, you need to unify the SecOps of the IT and the OT in order to work together, to work efficiently, and eventually see the global picture in order to mitigate the threats and the different attack vectors, even if they happen on cross networks, like starting from the IT environment into the OT one. Now let's break down each and every customer pain point and how it can be resolved eventually. First of all, as we mentioned, we talked about the asset inventory visibility. So today we encounter with customers that usually manage their inventory and fleet by a spreadsheet. That means that you need to create the spreadsheet, which is challenging, but eventually it can be done. But a much more challenging effort is eventually to maintain it. If now additional devices are being added or deleted, you need to maintain and provide with a real-time view for your inventory, which is something that is really challenging for users that don't have an OT security product within the organization. And what we want to transition is eventually to provide them with the real-time device inventory, to provide them with the visibility to what devices they have in the organization and what they are doing. And this is, of course, updated in real time and according to changes that we're now seeing in the organization. And in addition to know what devices you have and what they are doing, we also want to see the different connections between them. How devices are communicating between one another, what connections you have between a network and outside the network. So this is something that can also be achieved with an IoT security system. Now, in addition to that, we usually see that customers think of their organization as segregated networks. So, for example, they think that they have their production floor, that they have their enterprise network, and those networks are being segregated. Usually, they don't know that there is some sort of connection between those networks, and this, of course, leads to a threat of lateral movement. If an attacker now gains access to one of these devices, it can lateral movement and eventually reach every device within the organization. So using an IoT security system, eventually you can gain visibility and see what segmentation you have in your network. What are the different subnets that you have and how they are communicating with each other. And eventually you can see that these subnets, if you have now a cross or an interconnection communication between each and every segment, we provide you with the visibility, and eventually it enables you to enforce zero trust within your organization and make it much more easy, much more difficult for an attacker to perform lateral movement. Now, in addition to that, we are seeing also to provide you with risk and vulnerabilities. So until now, you can classify each CVEs and each vulnerability that you see in your network according to severity, whether it's high, medium, and low. But eventually, the goal here is to provide you with actionable step and insight, what you can do with this information. So the goal here is not just to provide you with CVEs and vulnerability, but also to provide you with a visibility to the risk. And one sort of visualizing the risk is to provide you with an attack vector. That means that the attacker can infiltrate to your network and eventually reach the crown jewels and cause and how it can affect the business impact. And then we can give you much more actionable or eventually critical CVEs that you can know that, for example, if you patch a specific device that is now on the way to this attack vector, this will mitigate this flow and eventually will reduce the risk. So we're not just saying patch all the CVEs that you have in your organization, but eventually we focus on the main devices that are now in the path of the attack vector and give you a justification to perform focused mitigation on those specific devices. And finally, we're reaching the step of detection, and now you can perform the investigation process. So until now, connecting the dots and perform manual investigation process once you received an incident or a threat in your organization was a process that took a while. It involved many people, many resources, different tools, and it's been done manually and of course took time, and eventually to perform mitigation is something that is a key factor here, because otherwise the threat can spread across your organization and perform damage that cannot be reversible. So our goal here is eventually to ingest all of the data into a unified database. And based on this database that we can use additional logic like machine learning and AI, we can gather all of this information and provide you with insights. And these insights, by the way, they're not only driven by the protocol insight that we're seeing. They can also be driven by behavioral changes, by devices and patterns that we saw in the past, and now we are applying into existing and future devices as we're collecting more and more information. And eventually it streamline the investigation process, make it much more efficient, and eventually SecOps mean time to respond is much shorter. And this is eventually our goal in order to respond and eventually recover from a threat. And finally, we also want to provide you with OT context. That means that we want to unify the SOC. We want, if you have now, for example, a cross attack that started from the OT network and now it's spread into the IT network, we want to provide you with a complete visibility, to provide you with an holistic monitoring, that the SOC will be unified, will speak in the same language, and eventually understand that if you now have a threat within your OT environment, to understand what it is, how it can impact your organization eventually, and whether it's critical to mitigate or not. And here you can see an illustration from our screen from Defender for IoT, how we map the different incidents into the MITRE for ICS framework. And eventually the goal here, and we spoke about it in the beginning, is to transform the different incidents and eventually the large amount of data that is being collected continuously into insights. And here you can see a different trend. So for example, if we are now highlighting in the heat map that initial access has many tactics and techniques that are being affected, eventually provides an insight to the organization that they need to mitigate the risk there. Because maybe you have too many connections to the IT network or to the internet, and eventually by visualizing them, that this is the main area that's required to be hardened and required to be remediated, then you can perform much more efficient investigation process and eventually provide you with clear visibility, and in order to address the critical threats that you have in your organization in order to perform efficient security posture. And finally, we spoke about how we can provide you with this visibility within the IoT security system, but we're also doing that by integrating with additional systems, CMDB system like ServiceNow. So with the integration there, we can also provide you with the visibility to your asset inventory. And by having this unique integration between ServiceNow and Defender for IoT, we are providing you with additional OT context. That means that you have a unique field like the Purdue layer or the specific OT type in order to understand what devices you have in your organization. And even now, if you're an OT context, an OT manager, for example, you can understand much easier what devices you have and whether they are now in risk or not. And in addition to that, we are also providing with vulnerability management capabilities, with the risk and vulnerabilities that can occur in each and every device, and how we can eventually impact your network. So all of this information is mapped into the unique scheme, the OT scheme of ServiceNow, in order to provide you with the visibility to those devices and eventually to the threats that might be related to them. And now over to you, Yair.
Thank you, Meir. That was really, really insightful. I'll start with discussing the ICS protocol challenge. I think that one of the largest challenges in securing critical networks is the breadth and depth of the different protocols that exist in the that communicate with each other with the different equipment, and the monitoring is critically depending on the ability to parse those protocols. Now, some common questions that might come up is what does the protocol support actually mean? So is it enough to just detect the protocol? Is it enough to retrieve the IP and the MAC? Or do we see what the PLC is doing and what state is it running? How good are the parsers? And when creating these new plugins, sometimes questions might come up that do you need to share the pickups with the vendor? Can the vendor create these dissectors by themselves? And how quickly is support added for new protocols once they come out? Now you'll hear yeah, we have support for this protocol, or it's coming out the next quarter. And what we are aiming to do is, because we understand that the protocol usage changes over time, and that even if one or two protocols that were originally supported, more will be needed in the coming in the time like that comes after the first deployment. We are aiming for an industry-wide community and collaboration for protocol support, and that's what I will be mainly discussing today. So Meir discussed in brief what Defender for IoT is. I want to stress the network monitoring part of it a bit more. So at the base, we have a network that we want to monitor. It could be a corporate IT, EIoT environment, or an OT environment with a car manufacturing plant, an oil refinery, PLCs, HMIs, engineering workstations. We will be ingesting all of this traffic into the Defender for IoT network sensor, a passive monitoring solution. And on top of this, we'll be able to see an asset inventory, vulnerability assessments, and general threat data. Now, to be able to do this, we have to have very good visibility into these networks. We need to be able to see the devices. We need to be able to see the connections between the devices. You know, Meir was discussing the supposed segregation of the networks. This is when you deploy this is where how you see that that's usually not actually the case, where our customers are always surprised at how many cross-subnet communications they have, cross-site communications they have. And at the very basis of the ability to parse this communication and see the different devices and how they're communicating with each other. And on top of this, we build real-time security alerts. So we can alert for unauthorized devices connected to the network, known malware, of course, unauthorized connection to the internet, and many, many more alerts that are there to protect your critical networks. At the very basis of our sensor is a DPI infrastructure. DPI is a deep packet inspection. If you want to be able to see more than just the IP and MAC of the device, you need to have a deep packet inspection for more layers of the communication stack. So our solution is built over plugin dissectors. That is the very basis of our sensor. For each different protocol, we create a plugin, and not only we create, you can also create yourself these plugins. I'll discuss this in a few slides. On top of this, of the plugin layer, we have the DPI services. So firmware detection, model detection, behavioral analysis, and all of this together is streamed into the Defender for IoT sensor platform, and it can be consumed on premises or in the cloud. Now, this framework is really powerful. It has direct integration, as I said, into the sensor, and it supports the data mining and custom alerts functionality of our sensors, which I'll show immediately. Now, each plugin that is created can be uploaded to the sensor without any downtime for the sensor, without having to wait for a maintenance window. So if you have a new protocol that you want to support, you can create a plugin and just upload it to your sensor. And here you can see how many packets per second each protocol is communicated in, what the bandwidth is. You might be surprised to see that a protocol that isn't significant for your operations is using a lot of the bandwidth and might be congesting the network. And that's something that you might want to look into. Based on this, we create data mining reports. So for any field that we extract from the protocols, we can create a data mining report. Here, for example, we see reports for BACnet protocol, but any protocol that we choose to dissect or that you choose to create a dissector for, you can then mine the data and just see any insights you need to be able to operate your network in a more secure way. So this is easily done, easily created, straight in the sensor. Another powerful and important use of the DPI, of the deep packet inspection, is creating custom alerts. I'll give an interesting example, relevant and actual from the pandemic. So at the beginning of the pandemic, we were approached by one of our customers, a large multinational pharmaceutical, manufacturer, and we were asked to help in protecting their COVID vaccine storage. Now the challenge was that this had to be done really quickly, and they were already a Defender for IoT customer, so they had sensors deployed inside their warehouses and in their manufacturing sites, and they wanted to know if we can monitor the temperature conditions and alert their SOC for a change in the change in the minimum temperature. So this has to be around minus 70 degrees Celsius. Not sure what the Fahrenheit conversion is, but quite cold. And we offered them a solution to use the DPI, the deep packet inspection, to monitor the refrigerator's reports to the PLC and to the HMI, and from there create custom alerts. So you can define a specific device, in this case the IP for the PLC that monitors the temperature, and create a custom alert. So a specific IP address and a specific value and object instance. So, and anytime the temperature is smaller than minus 78 degrees, please raise an alert. And that alert will show up in the SOC and can be immediately acted upon. And this was life-saving critical. I'm happy to say that everything stayed functional and the temperature stayed as cold as it needed to be. But we were able to offer them a peace of mind that they can do their job properly. So it's it's both security value but also operational value that can be created through these protocol dissectors. I'll continue, but with discussing our open development environment. So as I said, apart from the way we create plugins and upload these plugins and ship the plugins with our sensors, our customers and partners can also create their own plugins. They're easy to develop, and there's an interesting community here that's being built around this product, and I'll discuss these both. So, we have an issue with proprietary protocols, and sometimes customers are not willing to share sensitive pickups with us or with other vendors. This could be true for military, but also for manufacturing companies that do not want to share the protocols for their equipment. And what we offer here is the possibility to be able to create your own plugin without having to share anything with any sensitive information or pickups, no protocol spec with anyone. And this is done, the development is done in an SDK. So I'll show some screenshots of what it looks like, but generally once you've developed this, you plug in it straight into the sensor at the DPI level, as I showed earlier on. And this offers faster time to market for protocol support. You don't have to wait for a new GA version or an upgrade, no downtime. If you need to support a custom version of a certain protocol, for example, if in your environment you're using a different port than what is standard, so in a normal situation, without this possibility, most sensors wouldn't be able to recognize the protocol because it's a different port. In our case, you can just change the port with the ODE, and then you'd receive all the monitoring value and the security value. This doesn't add any performance overhead to the sensor, as it plugs straight into the very base layer of the sensor. It's not an aftermarket add-on. It's not something that you have to add on top. It's really at the very, very basic layer of the sensor. And our development environment supports debugging and performance testing, which I will explain shortly. The development is done in VS Code and is based on Docker. So if you have VS Code on your computer and Docker running, we can share with you the Docker container that has the whole ODE inside, the open development inside. The development is done in C++ and JSON. And there's also built-in debugging and fuzzing. So once you've finished writing up your protocol, you can debug, make sure it works as expected, run pickups against it and see that you're extracting the information that you want. And you can also fuzz the protocol, which means that we check that the inputs that the plugin is receiving are treated in a secure way. Now, the process for developing a new plugin is first to start with identifying the protocol that you want to develop. This might seem obvious, but it isn't that obvious, because identifying the protocol includes both understanding the specification of the protocol, understanding how it works, finding pickups for this protocol. Now, if you've developed, some of these protocols might have been developed 15 and 20 years ago. So that would be the first part, to define and identify the protocol. After that, we can start extracting the different fields. You provide a name for each field, link to mapping files for textual translation in the sensor. And the example for these kinds of fields could be function codes or firmware location, model. If we look at PLCs, then the PLC run state is a great example for an attribute we can extract from the packets. Once this has been written, once this has been coded, you can test your plugin straight in the ODE, and then package and deploy it to your sensor. And as I said before, all this without having without needing any sensor downtime. Now, we're building a community around this, as I started with, and we'd love for you to all be involved. There's already a GitHub repo. It's still in private, but we'll share links to join the community in the next few slides, and we're looking forward for all of you guys to be there. You can consult with community members, and if you wish to do so, share plugins and know-how with the community. So if I look at the key takeaways, I think from both what Meir and I said, and the first is that we're committed to providing an optimal security solution for OT and IoT environments. Defender for IoT offers unparalleled visibility into your environment, and we're not static. We're always building more plugins, we're shipping more features, but we're also offering you the possibility to extend our solution in any way you need. And the security community is looking forward for all of you guys to join. If a lot of you are probably already part of it if you're here on this webinar, but we'd also like to invite you to join the ODE community. I'll leave this open with some links, and you can scan the QR code. I know some security people in the room aren't too happy with scanning QR codes, so there's also a link you can type in. And there's time now for questions and answers. If there's anything you'd like to know, to add, feel free to write in the chat, and Meir and I will do our best to answer.
Let's see here. Thank you so much for that great presentation. It looks like, let's see, we've got one question coming up. So what does the license model look like? First question we have.
So the license model for Defender for IoT is based on the number of devices that are monitored. The pricing varies depending on how many devices you monitor. As part of the pricing plan, you have the cloud solution, the on-premises solution, access to threat intelligence, which is updated on a monthly basis and automatically sent to the sensors, and also access to the ODE, which is part of this licensing as well.
Thank you. And the next question is, right now, the solution provided depends heavily on the device map for attack path. Incorrect device map leads to different attack paths, and the default automated device map detection goes wrong and needs manual tweaks. Any suggestions or workarounds for this?
Yeah, so first of all, again, we're now, as Yair mentioned, we have different types of visibility in order to provide you with the most accurate real-time visibility to your devices, and eventually it will be translated into network connections and to the most accurate attack vectors that you might have in your network. So eventually, by adding more and more data sources, more and more machine learning and AI capability, we will provide you with the best visibility into your devices, which will eventually be translated into an up-to-date attack vector, and eventually to provide you with the most accurate way to achieve to your crown jewels and what needs to be mitigated in order to do so. So it's something that is constantly being improved based on the different technologies that we are incorporating within our product.
Okay, thank you. And that is all of the questions that we have for today. As a reminder, we have more webinars being scheduled right now. You can sign up for any of our webinars at aka.ms/security community. And I would like to thank Yair and Meir for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/security community. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.